To find the average atomic mass of an element, what we have to do is add up the different atomic masses of the different isotopes that we have. So in this case, we're going to do chlorine. Chlorine has two main isotopes, chlorine 37 and chlorine 35. So let's go ahead and add those up together right now. So the first thing we're going to say, okay, chlorine, and that would be chlorine 35. In our table, we're given the mass of chlorine 35 is 34.968852 AMUs. So let's just write that out. 34.968852 AMUs. Let's give a little space here. Chlorine 37, on the other hand, is heavier. It is 36.965903 AMUs, atomic mass units. And so what we have to do, we can't just add these two together and then divide by 2, because the percentages are not equal to each other. They're not the same thing. We have way more of chlorine 35 than we have of chlorine 37. So what we have to do is we have to turn these percentages into decimals. We have to turn them into decimal. And so the way that you do that is you have to move that decimal place over 2 spaces to turn it from a percentage into a decimal. Same as dividing it by 100 or multiplying it by 0.01. There are a number of different ways of saying that. So let's go ahead and do that. So we have to multiply. First, let's do chlorine 35. We're given a 75.77% abundance, so we turn that into a decimal as 0.7577. Chlorine 37, oops, put that in the wrong one. Chlorine 35, so 70.7577. For chlorine 37, we have a percent abundance of 0.2423. When that percentage was turned into a decimal, it was 24.23%. We made it 0.24233. So when you multiply those together, you end up getting as what I call like a molar share of how much you have. The amount in given 1 mole that would be made up of this particular isotope. What we do is 26.4960, and that would be, I guess you could say, grams per mole if we were talking about moles, but then you'd have to change this to grams per mole, because it's numerically the same thing. Instead of saying AMUs, which is the mass of 1 atom, we'll say grams per mole, which is the mass of 1 mole. 26.4960 grams per mole of chlorine 35. And then you multiply these two together, and you'll get 8.9568, and that would be grams per mole of chlorine 30. Sorry, that should be a big C, not a little c. Chlorine 37. Okay, then when you add these two together, what you end up getting overall is 35.45, and that would be grams per mole of chlorine. And so the reason why we have to round it to 1, 2, 3, 4 sig figs is because over here, the number with the fewest sig figs was 1, 2, 3, 4. And also as we added them, all of these digits went way beyond the 2 decimal places, so we'd have to go by the multiplication rule, which was saying the fewest sig figs, that's what we round to. So our answer for sig figs is 35.45 grams per mole. Okay, now let's go ahead and do iron, which was said, it said at magnesium, it's okay, it was a typo. So let's go ahead and do the same thing here. So iron 45 plus iron 46, iron 54 plus iron 56 plus iron 57 plus iron 58, adding up the fractions of all of these that we get. So we go 53.94 AMU times, turning this into a decimal, 0.0590. All of that plus 55.93 AMUs times 0.9172 plus, that would be 56.94 AMUs times 0.021, sorry, and then plus 57.93 AMUs times 0.00280. So that would give you the overall the molar share of each of these added together. When you add all of those four different isotopes together, what you should end up getting is 55.8, and that would be AMUs. And then, so one more time, the difference between AMUs and grams per mole. AMUs just refers to the mass of one particular atom, or one particular molecule if you have molecules. Whereas grams per mole, that is the mass of 1 mole of that type of atom, or that type of molecule. So numerically, they're going to track each other, but they just refer to a slightly different concept. So overall, 55.8 AMUs. And that is because we have to round to 3 sig figs, 1, 2, 3, because in this, if you look at all of our numbers, the one that had the fewest sig figs going in was here. We only had 1, 2, 3 sig figs. Here we only had 1, 2, 3. Everything else had 4, except for this 1, 2, 3 sig figs. Therefore, we had to round to 3 sig figs.